Chapter 15, Part 1. The title of the chapter is Temperature and Heat. In this part, we will talk about temperature. As you know, all matter, whether solid, liquid, or gas, is composed of atoms and molecules. And these atoms and molecules, they keep moving all the time, so they have kinetic energy. Now, the average kinetic energy of those particles cause the effect that we sense as warmth. So, when something is warmer, the kinetic energy means has increased. When the object feels colder, that means the kinetic energy of the atoms or molecules has decreased. So the main point I want you to understand from this part is that temperature is related to how fast are the molecules or atoms in the material. How high or low is the kinetic energy. Now, because as the temperature rises, this means kinetic energy is higher. So usually all matter expand with temperature. When the temperature decreases, matter contracts. That means it's becoming smaller in size. Now, to measure temperature, we use a device called thermometer, which shows the expansion and contraction of a liquid inside a glass tube. This is the shape of a thermometer, and you can see there's a liquid, the red one, inside the glass tube. Usually it's mercury. Now on the right there's a scale, a very famous scale. It's called the Celsius scale, which is used widely in the whole world except for very few countries. On this scale there are two important points: the 0 degrees Celsius and the 100 degrees Celsius. 0 degrees Celsius is the temperature at which water freezes. That's called the freezing point. 100 degrees Celsius is the temperature at which water boils, becomes vapor, gas. That's called the boiling point. Now, the distance between is divided into 100 equal parts. Each part is called a degree. Of course, there are also below 0 degrees. The other scale is called the Fahrenheit scale. Now, the Fahrenheit scale is not commonly used except in the United States of America. The number 32 in Fahrenheit corresponds to 0 degrees in Celsius scale, while 212 degrees Fahrenheit corresponds to 100 degrees Celsius. The third scale, which is preferred by science, is called the Kelvin scale. Now, in the Kelvin scale, degrees are having the same size as the Celsius scale, and we call them the kelvins. So each degree in a Kelvin. On the Kelvin scale, the number 0 is assigned as the lowest possible temperature, called the absolute 0. At absolute 0, a substance has no kinetic energy. The 0 on the Kelvin scale corresponds to negative 273 degrees Celsius. That's the famous absolute 0. Of course, these different scales, you can convert degrees or temperature from one scale to the other. I just want you to know how to convert between two scales, the Celsius and the Fahrenheit. There's a very famous and simple formula to use, which is saying that if you want to know the temperature T, let's denote T by temperature by T. If you want to find the temperature in Fahrenheit, so you can simply use this formula, 9/5, multiply it by the temperature in degrees Celsius, and then add to that 32. The answer will be temperature in Fahrenheit. So for example, let's say the temperature outside is 40 degrees Celsius. So how much is it in Fahrenheit? So we'll just go to temperature in degrees Celsius and we substitute 40. 9/5 times 40 plus 32, you should get 104 degrees Fahrenheit. So that's a very simple formula to use for conversion from Celsius to Fahrenheit. Let's go to the main point of this part. Temperature is related to the motion, to the random motion of molecules in a material, in a substance. In the very simple case of a gas, an ideal gas, temperature is proportional to the average kinetic energy of molecular motion, of molecular translational motion. Translational means movement in space. So as the molecules move in space, they have kinetic translational motion, and the average of that kinetic energy is proportional to the temperature. In solids and liquids, it's a little bit more complicated because there are more constraints on the motion of molecules. That's the same idea. So temperature is not the total kinetic energy of a substance. It's not the total kinetic energy of all molecules in a substance. What it is related to the average kinetic energy in the substance. So if you bring, for example, 2 liters of boiling water and 1 liter of boiling water, both of them have the same temperature, but they do not have the same total kinetic energy. The big amount of water, big mass of water, will have more kinetic energy. But still, the two amount of water will have the same temperature. Why? Because they have the same kinetic energy of molecules. Another example, if you bring a bucket full of warm water and a small cupful of very high temperature water. Now, the small cup has more temperature than the bucket full of water. But still, the bucket could have more total energy, even though it has a small temperature. Again, because temperature is related to the average kinetic energy, not the total. This is the end of the part 1, and I will leave you with one question. Question says, what is the relationship between temperature of a substance and the speed of its molecules? If you understand this part, you could easily answer this question. We will talk about it again in class. Thank you.